All right, so in this second video, we are going to start looking at some examples on how we can turn our domain from an inequality into an interval notation. So as you can see, we're looking at three number lines here. Because we're just looking at number lines and not coordinate planes, we are strictly just focusing on domain. We're reading from left to right. If we take a look at this first number line, we see that we start here at 0, and there is this closed circle, which means that we're either using less than or equal to or greater than or equal to. Now, as the line moves to the right, we are getting bigger. Okay, and as you can see, we have this arrow, and if there's no value that it's stopping at, that means that we are ultimately heading to infinity, right? So remember, if we're writing this as an inequality, we wouldn't say that we're heading to infinity. We would simply just say that x is greater than or equal to 0. That means that x could be 1, that means that x could be 2, x could be 3, x could be 4, x could be 100, x could be 1002. But if you were to substitute any of those bigger x values in, you would see that the inequality holds true. 4 is greater than 0. 8 is greater than 0, and so on and so forth. Now, if we take a look at this next section, there's a few other components to this. First off, we see that we start here at -5, and there is an open circle. So that means we're using less than or greater than symbols. And it really just depends on the inequality that we're going to be looking at, since it's going to be compounded, for us to determine which one we're using. And then we do get bigger, so we are heading to the right. And then we end here at 2, where it's a closed circle, so we would use less than or greater than symbols. Now, because we're talking about domain, we are going to always make sure that we're using x. And we know that we start here at -5, right? And we end here at 2. So we definitely want to put those values in order. And what we're trying to determine is if x is any number in between, let's say x is 0, right? Well, 0 is definitely bigger than -5, and -5 is definitely smaller than 0. So we would want to say -5 is less than x. And remember, we're using this less than sign because of the open circle. Okay. And then if we keep working with this, let's say we substitute in 1, right? Well, if 1 is x, 1 is definitely smaller than 2. Right? So we would say -5 is less than x, which is less than or equal to 2. And we're using less than or equal signs because of that closed circle. Now, this last one is a little different because if you take a look, they're not combined. It is two separate functions. One is coming from the left and stops at -2. So this is coming from negative infinity over here. Okay. And then it stops at 2. There is a closed circle, so less than or equal to or greater than or equal to. And then it starts back up again here at 1. So there was this gap. Okay. And then we have this open circle, which would be less than or greater than. And as we head to positive infinity, we know we're getting bigger, right? So this is actually an example of two separate inequalities, okay? If we're talking about just this first one on the left, if we're coming from negative infinity, we don't want to include negative infinity in the inequality. So we would simply just say that x is less than or equal to -2 because all of those x values get smaller. -3 is less than -2, -4 is less than -2, -6 is less than -2. And then because there is this gap, we would use the word or, okay? And we would say now and talk about this inequality. So we would say, all right, we have this open circle. We're heading to positive infinity. So we know that x is greater than 1. Now, x cannot be 1 because we can't actually buy some land, make a house. We can't plot a point there, right? We can only approach 1. So we start at 1.00000001, like something really, really close to 1, and then we head to positive infinity for forever.